everybody. Today we're going to be talking about section 6.3, which is about fuel types and uses. The learning objective that you're going to gain for today is being able to identify the types of fuels and their uses. Some of the essential knowledge we're going to learn is about wood as a fuel source, peat, the types of coal that are used, natural gas, crude oil, fossil fuels, and kind of how these are used for heat and electricity. So lots of things today. So we're first going to talk about subsistence fuels, which we briefly touched on in the 6.2 notes. So I'll just give you a little bit more of it here. So if you don't remember, these types of fuels are going to be biomass fuel sources that are easily accessible. They can be found or gathered by hand, and they're often going to be used in developing countries as a home heating or cooking fuel source. So the two most common of these sources are going to be wood and charcoal, which is derived from wood. But the reason why this is going to be common in developing countries is because wood is going to be free / cheap. You can cut it down, you can utilize it as fuel, but unfortunately this can lead to deforestation and habitat loss. Now, the other type is charcoal, which is basically just what happens when you burn wood, and wood is going to form into charcoal after you've burned it for a little while. So they're both derived from trees. This is what charcoal looks like. You have maybe seen this in the bottom of a fire pit before. So another thing that we have is known as peat. And peat is going to be partially decomposed organic matter, often like ferns or other plants, and it's going to be found in wet, acidic ecosystems like bogs and marshes. So this partially decomposed organic matter, you can dry it out and it can be used as a fuel source. So over time, when you've got these marshes and the vegetation, it's going to be kind of partially decomposing, and that's going to create peat in these areas. And as I said, it can be dried and used as a biomass fuel source. So this is what peat looks like when it's been kind of harvested, cut up, dried. Fun fact, this can also be used in gardens. But we're talking about fuel here. So it is also able to be burned and used as a fuel source, as a type of subsistence fuel. Now, the next one we're going to talk about is coal. And we'll start by how coal is formed. So coal takes a while to be formed, and it's going to be caused when you have pressure from overlaying rocks and then sediment layers. They're going to compact this peat over time, and peat is eventually over time going to become coal. So if we look at this diagram here, where you've got the peat, and then over time you've got the layers pressing on it, and then eventually you're going to get to coal formation. Now, these are going to be in different layers of energy density and quality. And if you look here, it's also kind of based on the timeline of how long they have had to be compressed. The more compressed they've been, the more dense they are with their density and the energy that is in there. And also, if we're looking at the quality of the coal that you are using. So this is going to go in order. We've got lignite, bituminous. Yes, bituminous. And then anthracite. And this is going to be in order from least dense to the most. So you can remember the lignite starts with L, so it's least dense. And then it just goes in descending alphabetical order after that, where you have the anthracite is going to be the most energy dense. So the deeper the coal reserve is buried, the more pressure you're going to have on top of it, and the more energy density there is going to be. So because the higher energy density means more energy is going to be released when the fuel source is burned. So this makes it so that for fuel purposes, anthracite is going to be the most valuable form of coal because it is the highest quality. So when you have ones that are more energy dense, when it is burned, that means it's going to be releasing more energy. So you're going to be able to use it better for fuel sources. So anthracite is going to be the best quality out of those options. Now, the way that coal is used, specifically if we're talking about like power plants and generating electricity from it, Coal is going to be burned in order to heat water. This is going to create steam, and that steam is going to go and turn a turbine that will generate electricity. And so that is how the coal is using, and it ultimately results in electricity being made. Now, the more dense the coal is, the hotter and the longer the fire will be, which will be the more steam, the more electricity, which again is why we like this anthracite best, because it is going to give us the most electricity. Now we're going to talk about natural gas. And natural gas is going to come where you have the decaying remains of plants and animals, typically in a marine environment, and they're going to be buried under layers of rock. And because of pressure, they're going to be converted into oil, which is petroleum, and then also natural gas over time. So natural gas is mostly going to be methane, which is CH4, and it's going to be found on top of that trapped petroleum deposits. So this is going to form when you have oil that's trapped in a porous and sedimentary rock underneath a harder, impermeable rock layer that doesn't let the gas escape. So as we're having this pressure and the natural gas is being formed and the petroleum is being formed over years, the natural gas is going to be trapped in that layer. So if we look at this here, we've got the marine organisms, and over time, you've got these different layers that are going to be forming. And since a lot of the area that we have on land used to be underwater, that's why even in the middle of Texas, you are going to be able to drill down through these different rock layers and eventually get to where we have trapped petroleum and gas down there. Now, natural gas is actually considered the cleanest of the fossil fuels, not of all the energy sources, but of the fossil fuel energy sources. And this is because it's going to produce the fewest air pollutants and the least amount of carbon dioxide when it is burned. So if we look here at the fossil fuel emission levels of how we've got carbon dioxide, carbon monoxide, particulates, mercury, etc., all those things, you're going to see that natural gas is going to be the one that is the cleanest of these three options. In fact, it produces about half as much carbon dioxide as coal when it's burned for electricity. It produces virtually no particulate matter. You don't get that soot and ash that you get from coal. And it has far less sulfur dioxide and nitrogen oxides than coal or oil does. And it has no mercury, none of it. And you do get small amounts of it with oil and coal. So it is the better of the fossil fuel options. Now, the next one is going to be crude oil, which is petroleum. So again, when we've got those decaying organic matter trapped under the rock layers, it's going to be compressed into oil over time. Now, the way that you get that out is by drilling a well. You go down through the rock layers to reach the underground deposits, and then you pump the liquid oil out under pressure. And as you can see, this can happen in marine environments, which is how you sometimes lead to oil spills in the Gulf of Mexico and other places, such as what we saw with the BP oil spill. And it can happen on land. You can also have oil spills on land. It just tends to be far less intense than when it's in the middle of the ocean. But either way, regardless of oil spills, this process is going to be, again, where you pump this liquid oil up from the pressure that you're putting down there, and that's how you're going to get these deposits out from underground. Now, another option that we have, which is even less environmentally friendly, is going to be recovering this petroleum from tar sands. And tar sands are where you have a combination of clay, sand, water, and something known as bitumen. And this is going to be, basically you can think of bitumen like tar. It's a thick, sticky, semi-solid form of petroleum. It's not liquid, and so it's not going to be easy to just pump out of the earth and to extract it. And so in order to get this out, this has actually become something that's more popular lately as we are continuing to deplete our readily accessible fossil fuel reserves. And fracking is going to be one of the ways that we are going to get this out. So in order to get this bitumen into a usable form, it takes a lot of water and energy. So it is definitely more intense. You're going to get a lot more going into the environment to make this process happen. And so it's going to be extremely energy and water intensive. You need to heat a bunch of water, which requires energy, which again, usually this energy is formed from fossil fuels being burned. But either way, you use this water, it's heated to create steam. You pipe this down into this tar sand and it melts the bitumen into a liquid that can then flow up a pipe. And we're going to have a lot of water that's having to be used to separate the oil from all of the impurities. Because when you get this liquid, it's going to have a bunch of like sand and clay in it. So you have to take it to a refinery to use even more water in order to separate this oil so that it can then be in that petroleum form that we can actually use. But Canada is actually doing a bunch of this because as they are depleting their regular petroleum resource areas, this is going to be where we are kind of moving, as we still need petroleum for a lot of different purposes in our world. So speaking of a lot of different purposes in our world, we're going to talk about how fossil fuels are used. So the petroleum that we just talked about is going to be converted into lots of different products through the process of fractional distillation. And this is where you take crude oil and burn it in a furnace. The vapor passes into a column where different hydrocarbons are separated based on their boiling points. So if you look at the different boiling points here, you can kind of separate it in this area, and you've got different uses. Like the one with the highest boiling point lowest boiling point is going to be petroleum gas. Then we've got gasoline, we've got diesel, we've got lubricating oil. So all of these are at different boiling points. And so it's going to be easy to separate out so that you can isolate it. Now, hydrocarbons that have the lower boiling point are going to gather at the top of the column, and the higher boiling point is going to gather at the bottom. Now, here is a list of ways that different hydrocarbons are used within this petroleum. So a lot of times we tend to think that oil is just used like for cars, but there's actually so much that it's used for. Yes, a large component of it is transportation, such as gasoline for our cars, or jet fuel, or diesel fuel, or motor oil. But we also have other purposes, such as using it for asphalt, for roads. Additionally, it is used in making plastics, which we have so many plastics. So we are going to have these fossil fuels needed for basically everything that contains plastic. So if you look around your room right now and you think of all the things in there that contain plastic, fossil fuels were used for that. So it's not just for cars, which is why it is such a booming industry and we are very much reliant on it. And that is why it is worth it for countries to try to make sure that they are able to provide it and profit off of it. Because all of these different products are going to be ways that the petroleum is used. All right, so this is going to be your practice FRQ for 6.3, where you're going to practice the suggested skill of describing an environmental concept and process. So your practice FRQ is, natural gas is considered to be a better fossil fuel for the environment than coal is. Explain 2 environmental benefits of using natural gas as a fuel compared to using coal. So that will be your practice FRQ for 6.3, and those are your notes on 6.3.